So today we're going to look at the volume of pyramids. And before I just straight out give you the formula for volume of a pyramid, I want you to understand the relationship between the pyramid and the prism in which it fits inside. And what I mean by that is you have two types of pyramids. One of them is a square-based pyramid and the other is a triangular-based pyramid. And so here's a picture of each. And if you notice, the square-based pyramid fits inside of this cube, and this triangular base pyramid fits inside this triangular prism. Now the reason why I have them in these prisms is because these prisms have the same height as the pyramids. This one happens to be a cube. And this prism, triangular prism, has the same height as that pyramid. Now one specific relationship that I want to show you is that this pyramid's volume will actually fit in this cube 3 times. And the same with this pyramid. And so here's another visual I drew for you. Okay, so I'm showing you that these 3 pyramids have the same height as the cube, the same base as the cube. So these 3 pyramids will fill up the volume of that entire cube. Same as the triangular base pyramids. These triangular base pyramids, each one of them together combined will fill up the volume of that triangular prism. This prism has the same height as these pyramids and the same base. Okay, so when that happens, you realize that if you want to find the volume of just one pyramid, then you're going to actually take the volume of this entire prism and you would just take 1/3 of it. So if I want to know the volume of this red pyramid, then I would take the volume of this prism and just take 1/3 of it. If I want the volume of this green pyramid, I would take the volume of the cube and take 1/3 of it. And that would give me the volume of that green pyramid. So I'm going to show you a visual with liquid and a more interactive way to see this. All right, so let's write down the formula for the volume of a pyramid. Now I wrote the volume of any pyramid because a pyramid is any 3-dimensional figure that comes to a point, right? A geometric shape on the base, and it comes to a point. So it could be a square-based pyramid, a triangular-based pyramid, it can be a pentagon, hexagon at the bottom. It doesn't matter what the base looks like. If it comes to a point, it's called a pyramid. And so this formula works for any type of pyramid. And it's going to be 1/3 times the base times height. Now, that capital B is going to be depending on what shape the base is. So if it's a square base pyramid, then the base would be length times width. If it's a triangular base pyramid, then you're going to use a formula for a triangle on the base. If it's a hexagon base pyramid, then you put the area of that hexagon as the base times the height. So that's very important. So let's go ahead and write that down. This will be the area of the base this is the height. All right, so let's look at the first example. Find the volume. All right, so let's draw a picture of this. It is actually a hexagon. 6 sides. And it's got a point. Okay. And it's telling me that the entire base is already calculated, and it's 48 millimeters squared. And the height, I'll do that in red, of this entire pyramid is 9 millimeters. And I just did it in red, so it's not so many lines. And the height is going to be straight from the center of the pyramid up to the top. Okay, so it's a perpendicular height. And so then we're going to use the formula 1/3 base times height. 1/3 the base, which we already know is 48, and the height is 9. And multiplying all of that together gives us a volume of 144 millimeters cubed. Okay. There you go. So one more example. We'll do 2 parts on the next example. All right, so let's look at example 2. Example 2 is asking us to find the volume and we got 2 parts. This time we have a rectangular base pyramid. Not necessarily has to be perfect, but give you an idea what it looks like. All right, and they're telling us that the height of this pyramid is 7 feet. That's going to be from the center of the pyramid straight up. And it's going to be 7 feet. Now it's important that I draw this little 90-degree angle here because it has to be the perpendicular distance from the top of the pyramid straight down to the center of the base. And then they're telling us that the width and length is 3 by 4. And we're going to find the volume. Now before we do that, notice that the volume formula is always going to have that base on there. So we need to find this capital B. And capital B means area of the base. And in this case, we have a base of a rectangle. Now it looks like a parallelogram because of the angle, but it's really a rectangular base. It just looks like a parallelogram because it's drawn in 3 dimensions. So it's really a 3 by 4. So the base is equal to 12. And remember, area of a rectangle is just length times width. Okay. So that's 12. So volume is equal to 1/3 the base, which was 12, times the height of this pyramid, which is 7. So that's equal to 28 feet cubed. All right. All right, let's do example B over here. This time we have a triangular based pyramid. And it's got a height of 10 meters. And the base is a triangle in itself, and it also has a height. And that one's going to be 6 meters. Okay. Now, what I mean by height of this two-dimensional triangle, okay? This two-dimensional triangle, that's the base, has its height. And then it also has a base on that triangle of 17.5. Now, when referring to the three-dimensional figure, that also has a height, a three-dimensional height of 10 meters. Okay, so those two different heights are going to be used differently. So let's see. 1/3 base times height. And again, we got to do capital B first. This time, remember, capital B stands for the area of the entire base, like this whole space. So that's area. And the area of a triangle, I know the formula for that is base times height divided by 2, in case you forgot. So the base, or the area of the base, is going to be lowercase b, which is a linear distance for a base. Capital B is an area measurement for a base, okay? So lowercase b would be this one here. 17.5 is the base of that triangle times the height of that two-dimensional triangle divided by 2. So now my base is going to equal 52.5. And again, 52.5 is going to be the area of that bottom rectangle. All of this. Okay. So now I'm ready for this formula. Capital B, which I now know is 52.5, times the height of this three-dimensional figure, which is 10. So now I have volume is equal to 1/3, and that's going to be 525. 1/3 of 525 equals 175 meters cubed. And that's the volume of that pyramid. All right. There you go. And that's how you find the volume of pyramids.